Okay. Testing, 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 testing. Okay. So this one. Okay. So something is crazy here, right? So you loop too much. Right? So maybe instead of keep doing this, maybe we can count them, right? So let's do that. Okay, so let's keep the K group and so we would have we can save a characters and how many they are, right? So for example, we have this guy. So first we got D1, right? And then we have 1, 2, 3. Right? So if they're not equal, then it's gonna be 3. Right? If it is right, if we do this, then we can delete this. Right? And then D go with this and 2. Right? So then D2, right? Then C3 keep going until it's gone. Then it make become B3, right? Because B3 can be gone, right? And then B becomes 3, right? And then gone, A2, right? Then we make the string. Right, let's try that. What we call this? Let's call this CC. Oh, characters count. Okay. So we start at 0, Y. let's put the clock in here, timer here. This is timer now. This is a stopwatch so that we can be mindful about the time. Right, so while look at the time scare me. Right. So if len.cc equals 0, we would just cc dot append si 1. Otherwise, if the character at the top, not the bottom, otherwise if it has more than one length, then we check with the top. So if the cc minus 1 at the top equal to si, and actually cc minus 1 plus equal 1, right? So when we plus 1, we gotta say if Goku K, right? Then we actually have to pop them, right? cc dot pop left, pop right, pop. Go. So first we see that this D1 and the Y, this is not equal to the top. Right? So if it's not equal to top, then we put A1. Right? Zero, or if not 0, then we check top. Not equal to si, right? So this means that if the length is not 0, then we have to check. So we check that, and then okay, if it is, then we keep doing this, right? So we keep doing that until we get to 3, and can we not check, right? Out here, right? If length cc is greater than 1, greater than 0, and for whatever reason the sorry k number and pops, right? So we see this, we pop, and character is D. We make it become 2, right? And then this is not equal, then we make B here. B count up to 2, right? So it's not equal again. C count up to 3, and we kill C. And B become 3 here, right? B become 3. Then pop this. Okay, I think it might work. So let's take this out. So then we just need to make the string at the end, which is return string buffer, right? So 4, okay, while length of cc greater than 0, right? Cc dot pop left, right? So this is character and the count, right? Say cdc is f, call this, right? So sp plus equals c multiplied by f, right? Something like that. Oh, what happened? Unterminated. What? Okay, fine. We'll just move this into this. Like that. And we use this test case, see if it passed. There we go. Okay. We have this. Okay. So we go, it took us 7 minutes. If we get the right approach, go to the next one. This is what. Okay. This is maximum product of selected binary tree. Okay. So let's reset the stopwatch. Split the binary tree into 2 subtree by removing the maximum product of the sum of the 2 subtree. Product of the sum of the 2 subtree is maximized. So we have to calculate the sum of everything, right? And so we got here 1 3 5. We can cut any of these, right? So that sound like at each of the node here it has to store the sum, right? So if we cut here, if we iterate over the node, right? We what is it? So can we not store at each node? Like if there's no tree, then the max is this. You can't cut, right? So then this is return 4, this return 5. So then the sum of these two subtree here is 11, right? So as we loop through these, we can store the sum of the subtree. So this is 11, 10, right? So if we cut here, we can look at the sum here. It's 11, and sum here is 10, right? So that gives us 10 multiplied by 11, right? So we cut here, it's give us modulo. Okay, hold on. If we cut here, we will have if we store all the nodes, right? You want to be able to say if I cut here, then if I'm here, I should be able to say what is my sum, right? To the right of me, right? So we store the sum of subtree here. Will we be able to figure that out, right? So basically we got here is we will have the subtree of these, which is 4, and we will ask the sum of the subtree here, which is 5, which is 10 minus whatever this is, right? Oh no, 9, right? This is 9 minus this, right? And then we need to know the sum of the parent, right? Right? So we got here we need to get the sum of the one on the right here, which is keep going to the parent, right? So basically until we get to the root, right? So we got here, it will make it become 2 3, that all of these has to minus 4, right? So like, right? So we have we saw the sum of the left and sum of the right, right? So at 2 we got 4 plus 5, right? Right. So at 1 we got whatever that sum is, which is, and plus the 2, right? So it will be 9 plus 2 is 11, and at 3 we got 6, right? So that is 6, 3 plus 6, 9, right? So now, is this true that if we cut this, we can cut any of these, right? We have to look through this and basically figure out the math, right? Okay. So we cut these. So we had a 2 here. We cut this, right? Then we have to keep if we cut 2, we're gonna get the right subtree sum, right? Okay, so this 5 plus all of these, so plus minus this, right? So that's gonna be 2 plus 5 plus 2, because we know the right subtree here is 9, right? So it's gonna be 9, right? Plus so so we just have to go back to the root, right? So 1 is 11 plus 9, right? 11 plus 9, right? So so sum up everything here is 11 plus 9 is 11 plus 9 is 20, right? Do we minus the total sum? If we cut here, right? It will be total sum minus the total sum here, right? So that is 4, right? Equal 16, right? So 7, 8, 11, Wait, hold on. 7, 8, 14, 17. Right, hold on. 11. Oh, we forgot to plus the 1 here. Right? So the root, the sum of total sum of including root is plus 1, right? So 21 minus 16. Right? So that is that. So we cut this. That's gonna be 21 minus the total sum. If you cut this, gonna be total sum of these plus this value. So that'll be 6 plus 3, right? Gonna be what? 12, right? So 7, 11, 12, yeah. So if we store like the sum of the left and the sum of the right subtree in here itself, right? So when we cut this, we go in here and we say, oh, gonna be total plus this. It will be total sum of left, right. So this will be whatever this is plus this minus this plus this, right? So we need to store the pointer to okay. So we need to store the pointer to the like the BFS, right? So or DFS doesn't matter, right? So let's write basically have the DFS into starting at the root, right? So we would store them in nodes, right? DFS start at node. All right. So basically you just do a traverse, right? Right. So we start here. We're gonna keep exploring these. The first node, we go 1. We go here, right? So So we have to keep going left, and make note of the parent, right? So we have and basically the parent is none, right? We do like this, go like this, and the right, and visit this, and put left, right, this left, right, and then pick this, put this left, right. Right, if it is none, then okay, let's just do a function then. We'll do this might be easier. Right, we start at the root, we have a parent, we have first root, the parent none, right? So we want to keep going to the left, right, left, and we want to go to the right, and then after we going, we know the sum, right? So if not or, then turn 0, right? So turn 0, and then the node dot sum be equal to okay, left subtree, right subtree, right? So that give us and that means we visited this node. Then we would add them to the nodes. If we want to track them, loop them, and R, right? So this is R. Right. Do we need the parent though? Probably not. Okay. And we're done with this. Then we visit this. We're done with 0, 0, 0. And basically we gotta return or the sum. Right, so this return 4, this return 5, that's 9. And right. So oh wait, hold on. So this is R dot value plus. So 2 plus 9 gonna go up. Right. This is 9. And 9 plus 2. 9 plus 2 can go up to 1 here, and so on. Right, so now we know the total sum gonna be total sum gonna be plus, oh, that is the total sum. Soon as we finish, we go back to root. Right, so now we got the go loop through all this and try and cut. Right, okay, so for node in nodes, right, if we can cut, if node left, cut here, if we cut here, we can't cut here, right? If node left, this has node left here, right? Then max value, what is it? Max product. To 0. So if we can cut here, right, then it's gonna be the entire sum minus the sum of the left subtree, right? So if node left, max product equal so we need to find the value, the tree, let's call this, so if we cut this, the value of the first tree, tree that including some tree including node, some tree node left, right? Gonna be node left sum plus node, right? This is true though. Hold on. If we cut here, then it's gonna be the other sum tree other gonna be total sum minus sum gonna be 0, right? Plus 0 plus 4. So sum, this is 4, right? So it's gonna be that, right? Total sum minus load node dot left or sum, is that it? And then max product equal max of max product and sum 3 other multiply by dot node dot left dot sum, right? Multiply. It's multiply, right? Yeah. So I'm assuming this is the same. So maybe we can do C in right, if C, if not C, then continue. Right. If that's C, then sum no C equal to total sum minus C dot sum. So child sum no child. Right, so we do the same thing here. No child multiply by child dot sum, right? Right, so let's see if we even correct it between total sum then max product mod 10 to the 9 plus 7. Right, maybe this will work right away, maybe not. In object have no attribute. What? Start at root. Or do we have to store them in the map now? Can we hack this with this dot thing? Or is it part of the init, right? Oh my god. So something not good. Not child. That. Okay, maybe that works. Let's see. Yeah. Congrats. Claim now. So let's record our submission here. Oh, what do we do in 2022, bro? That's crazy. Okay, let's look at 2022. What do we do? We did the same thing, guys. Oh my got. Oh, we track them in the we track them in the dictionary. It's interesting to look at. Oh, submission. We did not do things differently now. I'm thinking, okay, fine. Okay, so should we take a break or should we try some quiz? What is it? What? It's quiz. How many questions? Hey, I don't want to do this. Let's just do quiz later on, guys. Do quiz later on. But it is time. Be fine. We only have like 1 hour left, right? Do we want? Just 2 hours. Let's do a couple practice one for this. Seven. Come on. Number mode to make. So it has to be valid, right? So that means if we see no match, we delete them, right? Right, we see this and right, so if we see no match, we delete, right? No match, and we just delete the string, right? We can only remove, right? We can only remove. this is valid, but this, if there's no corresponding, then we just skip them, right? Skip them. And finally, we have to also delete these, right? Because mm, um, we do a stack for that. We, what's the difference between this? Oh, we remove that, right? So we remove this. We keep this. For this one, we remove the one in here, right? So seems to me like a safer implementation would just be, if we see match, we if we don't see match, we just skip and we go on, and yeah. And for this is the same. Right? So what about this case? Fumble so much. What about this case? Right? We have this and this. This is no match. So we want to do this. AB CD. So then we have to remove this, right? So it's going to be ABCD. Yeah. So if there's no match here, right? We can concatenate everything up until that point, right? So after that, we still have these as the one that no match, right? We want to, for everything in between, we want to grab them, right? So we want to store the index, right? So let's try that. Stack equal my favorite DQ, right? to 0 first, while if I so if si equal to this, and we will build the string up until that point. Si. If it's closed, right? There's nothing, no match on the stack. It's length of the stack to 0. Then we just skip over it. Right? So in the meanwhile, SB plus equal SI, right? We do this, do this, do this. And we found this. So everything stopped. We do this, we do this. Forget about stream photo first. If there's no match, which means, so if we found match here, right? So then we can get everything in between, right? So let's put them into some comments here. So first we got everything here is everything between these we can get, right? So the next match here we will get everything in between T and O here, right? Okay. So this is 0, 1, 2. So when we match everything in between these, including them, can be half. So here, right? So basically we do this and we add this and everything in between. So the next time we see here, we match these. So okay, if we can match these, right? So that up until this point is fully formed, right? So do we just increase the right? So now we get this, and we don't match anything. We don't match anything. We just increment, right? So let's say we see this and there's no corresponding. Then everything up until that point we get, right? So basically beginning up until that eye, right? Which is we remove this, then continue. So we have this. So the moment we match, it sounds like we need a J here, right? It's gonna be J equal that, and J plus equal 1, right? J equal to I plus 1, right? Okay, so let's run to this. If it has this, we apply them. And so on. Or do we want? So let's say there's no match. Then it's gonna be this match.
It's confusing, bro.
There's no match, then basically we want to remove them. That means we got everything up until this point. So J is 0. Is that right? And J gonna start at this, right? There's match up here, okay. And you get some water.
Okay.
Okay, if there's no match, we want to skip them. there is still open, then copy in between them, right? So now hold on. For this situation, we have here, and this is match right here. When it is match, mean everything in here will need to store, right? So somehow we need to get C and then put like this, right? Because they match and they match again. That means got T here and O here. And we close it again. Okay, so if we match, we want to populate like that, right? So our string grow out from the middle, right? And then we see basically, can we not at the front as the back, right? We could do that. And basically when we match, we're gonna do this, and when we match here, how do we know what from to here, right? Or simply be right, is the goal. Oh, it's 1 hour stream already. Maybe 20 minutes. Oh, we should change this to 7. 7. Right. So we want valid parenthesis. So this is like finding the last index to match to, right? But we have here, there's no match. It's gonna be 0, right? So we could do that. Okay, so this match, good, pop. This match, pop. If there's nothing, then everything gonna be 0, right? So then we can copy everything over, right? So let's see if that works. Okay, so we found, good, we copy everything beginning, to this, right? And then we start at this. Okay, good. So we kind of need another J characters to, okay. So we keep finding no match here. Okay, so hold on. So we found this at this position. If it has the character, then it should have a J, right? So then it's gonna be everything up until this point, 0, and J gonna become this, right? So it match, let's just say, right? And if we go to the end here, if there's no, means full form, right? Then it's gonna copy these to the end, right? So we append this. Maybe J equals 0, good. It'll be J to the I, J to the, including I, right? And then J gonna become okay. So how do we do with this case? Okay, J here, no match, should be empty string, which is from 0 to, right? So J, next J should be here, right? And I minus J, I minus J is greater than 1, right? Right. So we out here and we see, okay, so this is all the open parentheses that we couldn't match, right? So between these we had to copy, right? So basically right, so another case is if length of stack equals 0, that means fully string is invalid, then basically that is J to the N, right? So like this case, when we see this and there's no match, J gonna start here, right, to the end, right? Else, right? So J start at 0, and J gonna be this. So J gonna be this already. So basically we have to copy between starting at J, right? Okay, so what about like we have in this case here, right? So let's return this case right here. So we have BCD, right? So we're gonna loop start at J to J start here already, and we want to remove these, right? So it's gonna be J here. So J will always be less than, right? So it's gonna be like 0, 1, for example. Zero, 1, 2, 3, 4, right? So 4 now. 5, 6, 7, 8, right? So that is 7, 8. The stack right now has 7, 8. So we want okay. While length of stack greater than 0, right? Then stack dot top left, right? In here we have position I, right? So SB gonna plus equal S starting at J to not including I, and J plus equal J equal I plus 1, right? Right? So we gotta say if J minus I minus J, right? Distance between them is greater than 1, then we can do that. Then J equal I plus 1, right? Like that. Unnamed string literal line 7. What? Okay. What's going on here? Like something off by 1. Okay, let's see if we can fix this. Okay. So we found here, let's print the stack. Character this, current value of the stack is 3. Right, so 3, 5, 3, 5. Oh, if it is match, then we want to pop the stack, right? Else match if then stack greater than 1, then stack dot top left, right? So with match, then the J gonna be at least the 0, 1, 2, 3, 4, 5, right? Right. No match, then J gonna be 0, right? J will be okay. Just pop left and see what happens. Oh wait, pop right, right? Okay, so match that. B and 5 and C. Vector C. What? Okay. So this is match. Then we just pop. This is match. We just pop. And this we couldn't found, right? So then will be 0, right? If we couldn't found any match, it will be whatever the J, right? Then up by 1 somewhere. B, B, C, D, C, D. Yeah, we missed a C, D here. Right. Okay, so first is empty E, okay. So let's just do this. Right? Put them down there so you can see the effect. Okay, so we do that, then do that. Put that in. Okay, see. Do that, we unmatch. We match. And finally that. Then if it is that, let's see what is the content of SP now. Right, so lead code. What did we miss? So this match T open C. This match O and this match, right? So 1, 2, 3, 4, right? Dummy. D is here. D, E, and S, B. if there's no match, then we want to go on the beginning. This match, let's print the match here. Oh, we gotta do this. Elif. You don't want to do two effect. Right? So okay, we match this and we do this. Okay, that's good. What about these? Um, we get 1 here minus has to greater than or equal to 1, right? Okay. A, B, B, C, D, C, D. Okay. Okay, so then no match. We actually add this character right here. 1 minus that has to be greater than 1, right? Because we don't want to include them. So I right now is that we gotta do is greater than 1. Up by 1 here. No match, right? If there's no match, we want to count these, right? We start at 0. Oh, if I minus 1, not counting this, minus j greater than or equal to, so we at 1. If 1 minus 0, oh, bruh. If 1 minus the beginning is 1, okay. Greater than 0, right? Then you can do that. Okay. That fix that, but did not fix these. So we match this. J gonna be hopefully starting from here, right? Oh, so let's print the I and the J. J here. Mm, so hot. So we are here. If we are here, we couldn't find match, and basically we want to say that if J is not equal to I, and I minus J, so 0, right? 1, 0 and 1, that's I minus J plus 1, right? So 1 greater than or equal to 1, right? 1 here minus 0 is 1, 1 is 2. Wait, what? I plus 1, same, right? One minus 0, right, is 1. Let's do that. Why does it still do that? Ooh, it's like 46 minutes now, guys. We found this, nothing good. We found this. So J now gonna become this, right? So do no match. This is J and this is I. Okay. So 1. Oh wait, hold on. So first it's equal each other, so we don't count that case. That case good. This one. So now J gonna be I plus 1. J should be 1. Why is J 0 here? Okay, so if there's no match, right? If so, regardless, j equal this, right? Like that. Okay, now we fix that. For this case. Okay. Maybe this is the one where we just need to do the same thing here. Right? We need to go out here. J stack. And SB. Okay, we got AB here. Zero, 1, 2, 3, 4. Good. Okay, so 7. So that's gonna be like that. Got AB, BCD, AB, BCD, and CD. We're missing CD, right? So let's see. Let's look at. Let's print the value of JI here. Four to 7, good. 4, 6, so 4, 5, 6, 7, good. And oh, so basically we need I equal -1, right? So SB plus equal S at the end here, right? Is the J gonna be 8, right? Oh, it's actually just gonna be J to the end, right? Okay. Okay. String parsing is still a problem for me. Too many conditions. Okay. See if this works.
Yes.
Very nice. This is so this is time taken here is not good. Right, but that's fine. This is okay. So we go to the next one. Find median of two sorted array. Given two sorted array, so do we want to do the hard one up front? Is that medium? the end to sort it already. This one we done. Right. Let's just do this first. Let's just and stop what? Reset. Given. Using the original letter exactly once. So can we now just build a frequency? Right, so eat. Eat and this is the same. So basically we can sort this guy. Is the word have you return answer in any order? All the original letter exactly once. So we can sort these, right? And it will become AET, right? So every time we go through each, we sort this and we check the frequency, right? Right? Just try that. I don't know. I think that will work. The reason we do that is because then it goes to the same entry, right? Okay. So result is this. Um, or is it possible? Is it possible for us to just sum the number together in ASCII, right? Or is it true, false, positive? So like if these sum to some number, all of these sum to the same number. Let's try that. or string in strings, right? Um, let's call this hash-sum, right? Checksum, hash-sum equal sum up. Do we convert it to right? HS. Let's just call this HS. Okay. So if length s, it says not in the frequency, right? We do length s because I don't know if there's any other number also sum to the same value. I don't think so, but let's be that, so I don't have to sort, right? Because then we can do O N, right? Yes, just this. Pen S, right? Now or whatever, right? In F, right? Can we not return group.value? Oh, I knew it. Okay, or whatever. Oh, just do this, right? Okay, fine, dude. Can we not convert them to this? Let me try that. Ooh. Wrong answer. this one here, man. Bye. Đó. Này. Odor and eo is the same. Right, so let me do this. Let's go so. With the file as you go here. Wow, oh okay. So this is too risky. Let's just sort that then, whatever. Python sort string. Join sorted fine. So my guess is the passcode is not in. What is a good okay, hold on, let's see if we can improve. Let's see what is the thing here, right? Then we don't have to convert them to this. Right, use test case, run. Submit. Group anagram. All right. So question here is, if I switch to this, and do this, will this improve? Whatever. No. Still best. So if we could so go back to this one. Median up to sorted array. The overall runtime complexity should be log n plus n. So if you merge them, right, that is O n. Maybe give this 5 minutes. If I couldn't think of anything, probably we should end this for now. It's getting to 2 hours now. Sorry. Um. So the medium is the middle, right? That sound like we know the length of the two array, right? So if somehow we can end up in the middle, that should be great. Right, so we have we know the end of one and the end of the others. So the first thing we know is if the array is not overlapping, right? So we know the length of two array, okay? So like 1 and 3, so that's 2, and the other one is 2. Right, so we have 1, 2, we have 3, 4. Right, so if the length is equal and no overlap, then it is the end of one and the beginning of others. Okay, so let's write down. If length is the same and one is the other, no overlap. That mean be like min, right? Min of min, right? Oh, max min, sorry. Be max of one, min of the other, right? So let's say we have 1, 2, 3, 4, 5. We know the number element, right? So this is 2, 1, 2, 3, 3. So its length is the same. Well, actually, let's call it a day now. I will have to play game with the bed.